Okay, for the second page of this handout set, we have two given independent events A and B, and the respective probabilities we have at 0.35 and at 0.60, and with the determination of the first part, and that is where we were looking at the probability that both A and B will occur simultaneously. Okay, now for this result we have, in terms of what to do with the numbers, well, A and B are independent. So for the probability that both A and B will occur at the same time, okay, with independent events, you want to take the product of the probabilities of A and B, again, to determine the probability that the events will occur simultaneously. And so we have for P of A, okay, we have at 0.35, and we have for P of B, that is going to be at 0.60. So for the probability that both A and B will occur at the same time, okay, that is going to be at 0.21. And now, okay, with these events, okay, so you have probability that both will occur, we have at 0.21, and we have the criteria necessary to solve for part B, and this is the probability that A or B will occur. And so with this one, okay, we are looking at the addition method. So you have the probability that A is going to occur plus the probability that B is going to occur. And then we have minus the probability that both A and B will occur simultaneously. And so for the probability of A, again, we have at 0.35, and the probability of B we have at 0.60. And again, just determine we have the probability that both A and B occur simultaneously, we have at 0.21. And so the probability that A or B will occur, okay, we have 0.95 minus 0.21, and so this will be at 0.74. And in the lead into what we have for part C, okay, we can look at this in either of two ways. Okay, now for part C, we have the probability that neither A nor B will happen, and you can set up a table, or you can say that, okay, from the what they call the Boolean algebra, okay, we had the probability of the complement of A or B occurring, and that is going to be the complement of what we have for part B. So you're looking at 1 minus the probability of A or B happening, so that's going to be 1 minus 0.74, which in this case is going to be a 0.26. And now with the same data, okay, using this as a backdrop to looking at the conditional probabilities, okay, let's say that for what we have in terms of what we can have boxed in, okay, so we have for the events, okay, we have A, you have A prime, or it could be A with a bar going over it. You have event B, and the non-occurrence of B we have at B prime. And so with the numbers we have at hand. Okay. Alright, so again, the probability of A we will have at 0.35. Probability that B occurs, okay, is going to be at 0.60. And earlier attained, okay, had the probability that both A and B will occur, okay, again we have at 0.21. And if you consider that the sum of all the probabilities, okay, will end up at 1. Okay. Now for B happening, we have a 0.60. Probability that B does not occur, that's going to be at 0.40. And in terms of what we have for the row, at the bottom we have probability of A at 0.35, and the probability that A does not occur, that's going to be from the remainder of the 100%, so we have 0.65. And for the remaining sections, okay, now for A, okay, have probability is going to be at 0.35, and 2100ths of this is going to be when B occurs, but outside of B, okay, that number we have at 0.14. And for B happening while A does, again, you have at 0.21. Probability that B occurs is at 0.60, And so for B to happen outside of A occurring at all, okay, have that number is going to be at 0.39. And then for the probability that neither A nor B will happen, okay, we can arrive to part C, that answer in this with this particular approach, and you still end up with 0.26 as a probability that neither A nor B will occur. Now, in what we have in part D, okay, we're looking at conditional probability, and we're looking at the probability that A will occur given that B is already occurring, or B has already occurred. So with the numbers that we have present, we can intersect, in other words, take the probability that both A and B will happen relative to the probability of B occurring at all. And so with the numbers here, okay, for both A and B happening, again we have at 0.21. Probability that B occurs, again we have at 0.60. And so for what we have here for 0.21 over 0.60, okay, that number is going to end up at a 0.35. Now, in the case of what we have in part E, okay, we're now looking at the probability that B is going to occur given that A has occurred. Okay, so you're looking at the probability of the intersection between the same events. Now it's going to be relative to the probability of A occurring. So we have, once again, B intersecting A. Probability, again, we have at 0.21. A intersecting B, B intersecting A, same number at 0.21. Probability of A occurring, okay, we have at 0.35. Okay, so for 21 out of 35, that number is going to end up at 0.60. Now, in the case of what we have for part F, we're looking at the probability that B is not going to occur given that A has occurred. Okay, so we have for the probability of the intersection between B not occurring and A occurring, making it relative to the probability of A happening. Okay, we now have in this particular situation, okay, what is going to happen in this particular instance is that for the numbers that we have, okay, resuming, okay, just got a little bit cut off right there. Okay, now for the probability, okay, that B is not going to occur given that A has occurred, okay, we're looking at the intersection between the non-occurrence of B with A relative to the probability that A is going to happen. So for the numbers here, okay, so we have B prime and A, so you have this number is going to intersect at 0.14, and the probability that A occurs overall is going to be at 0.35. So you have in these numbers, you have 0.14 over 0.35, and 14 out of 35, okay, well that number is going to be at 0.40. Now, for what we have in the case part G, okay, we're looking at the probability that now B is going to occur given that A is not going to occur. And so for what we have in this one, we're looking at the probability of the simultaneous occurrence of B while A does not happen. So you have intersection, and again you have that probability relative to the probability of A not happening. Okay, and so for the numbers, once again for B intersecting A prime, okay, that number, okay, we have at 0.39. Probability that A does not occur is going to be at 0.65. Okay, so for the numbers here we have 0.39. We have out of 0.65, so for that probability that is going to be 0.60. Now, in the case of what we have in part H, we're now looking at the probability that A is not going to occur already given that B is not going to happen. And so for what we have here, we have the probability that neither A nor B will occur. So we're back to the intersection relative to the probability that B is not going to happen. And so for the numbers here, okay, we have in this one case, so you have for A and B not occurring, you have at 0.26, A prime B prime intersect at 0.26. Probability that B does not happen is going to be at 0.40. Okay, so you have 0.26 out of 0.40. And so for what we're going to end up with in this particular instance, okay, 26 divided by 40. So for this conditional probability, okay, this is going to wind up at 65%.